Hi, welcome to the notes for 4-3, Solving Equations Graphically. Our attempt here is to put together everything that we've learned here about graphing and solving equations algebraically. To get started here, we have an equation that says the square root of x plus 2 equals x. The directions say how can we solve the following equation? Well, we're going to solve it both algebraically and graphically. So, solving it algebraically, let's set it up. We have the square root of x plus 2 is equal to x. And we know that when we have that square root isolated here, we can get rid of it by squaring it, but we got to square the other side as well. We're going to end up with x plus 2 is equal to x squared. Since this is now quadratic, we need to set it equal to 0. So let's go ahead and subtract our x and our 2 from each side. We're looking at 0 equals x squared minus x minus 2. That factors, so we'll have x minus 2 and x plus 1 equals 0. And when we set each of those factors equal to 0, using our zero product property, we'll get that x equals 2 and x equals negative 1. Now it's always important to go back and check them there. We'll take our 2 and we'll plug it back in. We've got the square root of 2 plus 2 should equal 2. Well, that would be the square root of 4 equals 2, and that seems to work. When we plug in the negative 1, we have negative 1 plus 2 under the square root equals negative 1. Well, negative 1 plus 2 is a positive 1, and the square root of 1 is just 1, so that doesn't work. If we're talking about what is our solution, we're looking at x equals 2. Now, without having to go back and check every single time, is there another way to solve it so that we can actually see what the answers are? And that method is going to be when we do it graphically. We're going to solve this graphically in a way that you haven't done it before. What we're going to focus on here is we're going to take the left side of our equation and we're going to make a function out of it. We're going to make that y equals the square root of x plus 2. And then we're going to take the right side of the equation and we're going to make a function out of that. We're going to say that's going to be y equals x. We're looking for what values of x would make that equation true. Let's start out here. We're going to graph the y equals the square root of x plus 2. Our locator point should be the point negative 2, 0. And because it's a square root function, we know we can go to the right one and up the square root of 1 from the locator point. Our stretch factor is just 1, so we don't have to move it any higher. We can go over 4 units to the right. The square root of 4 is 2, so we'll go up 2. We're at the point 2, 2. And then we can move over 9 units there, which should take us all the way over to positive 7. And then we're going to go up the square root of 9 units, which would be 3. If you forget those patterns for transforming the parent functions, okay, remember you can always just take inputs and plug them in to get them out. Or in this case, you can even use your graphing calculator to help you make sure you have the points in the right places. So that is our y equals the square root of x plus 2. And now we're going to graph the y equals x, which is just a linear equation. Our slope is 1 and our y-intercept there is 0. So it's going to go right through the origin, and since the slope is 1, we're going to rise 1 and run 1. So you'll see that we get a line that goes up kind of at a 45-degree angle there from the origin and the x-axis. We'll sketch that in here. Okay, so now you'll notice here that we have at that intersection point. And at that intersection point, the x-coordinate is 2. Right? Didn't we say that 2 was a solution when we solved it algebraically? So when we plug in 2 into each of these equations, we get 2 is the output for our y, so 2 works there. And when we plug into our square root of x plus 2, we get 2 equals the square root of 2 plus 2, which also is a true statement. Okay, now that means that, when we solved it originally algebraically, we saw there was one solution, and you see that there's one intersection point there. That's really important to know. So there is only one solution. Our solution there is that x equals 2. Now reading below, it says when a result from solving an equation does not make the original equation true, it is called an extraneous solution. You need to make sure that you know that. That's an important term. Extraneous solution. So when it comes down to it here, we had an extraneous solution above. Our extraneous solution was that x equaled -1. If you look on the graph, where x was going to equal -1, right? We have one of our -1s is here, and one of them's up here. It actually does not intersect, and you can see that down below here as well in the graph down here. Okay, if we would have had a full sideways parabola there, it looks like it would have intersected, but because it does not intersect, this part does not intersect down here, we don't have that second solution. All right, so let's move on here to the next part.